Okay, so this video is going to be a continuation of the last one, where we built a function to evaluate a series approximation. The only thing we're going to do different in this video is have multiple outputs, specifically the value of the series sum, the number of terms that were added to reasonably approximate the equation, and then also the amount of time it took. And one thing I wanted to touch on, which I didn't really talk about in the last video, is saving your file for a function. If you notice, I have this file stored in a folder, which is under my Matlab folder. And I actually went back over here and told the computer to go look there. I don't know where it was, but you don't really need to worry about it. As long as you save this file in your Matlab folder, usually it will go, it will know where to look. So, for example, if I type path, these are all the places that Matlab knows where to look for functions, for scripts, and this is always, it's always going to be there. So that's, in the earlier classes we've talked about just throwing it into the Matlab folder. If you're not really comfortable with this, just do that. You don't have to worry about it, but it is important that it's there. But anyway, we're going to continue on, and like I said, we want to have 3 outputs. So the next output is going to be number of terms, and then finish, which I had used in the last example, and it's just going to denote how long it took to evaluate the series approximation and add terms and stuff, all that. So everything is going to proceed as normal, but now we want to specify our outputs. So as you can see, we had our value equal to the series sum, but now we also want a value for the number of terms, and that's going to be number of terms equals, and just going to be equal to count as before. So count, and then also finish. We're going to have to define top first. We haven't done that yet, but so tick first. So I'll say, so tick can go up here, and that's going to start the timer, and then we're also going to have to stop the timer. So that can be done right here, and we're going to store that in a variable called, I guess we'll call that stop for now. So talk. Let's stop the timer. And so then we'll store stop in finish. And really, if you wanted to go this way, you can do finish. It's probably going to be a little bit faster, but I'm just going to keep it how we had it. So stop. And that should work. So let's see what we have. If I do that, I'll print exp4, exp of, and we should have 3 outputs. Okay, maybe not. How about we do exp4 terms and then time. And that should work. So now, there we go. We have the value of the series sum, we have the number of terms it took, and the amount of time it took. And as you can see, we did that by specifying that there were 3 outputs, and we wanted to save them in different variables. This actually came up when we used the fopen and fwrite. I think specifically it was fread. I'm not really sure, but for example, they have multiple outputs, for example, to count the number of bytes that were returned. So this is really a basic example. It just shows you how you can have multiple outputs for a function. And really, you can do that to do anything in your program. But this is an important thing to know just in general. If you wanted to practice some more, you could try using a for loop, for example. You could say for I in 1 to, sorry, it's different language. For I in 1 to 5, we want to evaluate our our functions. So let's say values I equals my approximation I, and then so that will store that in a values, and then you can have end. Let's run that, just see what it gives us, and then I'll print values down here, and we got the same thing. We should have gotten the same thing as in the for while loop example, but this is really just a concise way of doing that without a lot of cluttered code. You can even do different plotting examples. So you could say figure 1, plot 1 to 5, and then values, and you should get a line once this comes up. I haven't plotted anything yet, so usually takes some time. But here we go, as you can see. As we get to a greater number of terms, it looks like we need to add a bigger number of terms. Or sorry, as we get to a larger integer, we need to add more terms to the series to get an accurate approximation. But that's